All right, so this chapter deals with exponential functions. Which are written in the form of y equals a times b to the x, where a is our starting value. Okay, it'll also be referred to as our 0th term. And b is going to be our multiplier. Okay, which for today is also our rebound ratio. Okay, so let's say a ball is dropped from 150 feet. And it bounces up to 115 feet. And we want to figure out how high it's going to bounce on the 6th bounce. All right, so we can make a table, right? One way to do it. Okay, 6 isn't too far away. It's doable. Start at 150. We know the next bounce is at 115. Okay, so we need to find our multiplier. Okay, let's just call it 0.77. Well, it's probably rounding. We'll go rebound ratio of 0.67. All right. So that's our rebound ratio. If we want to find the next one, we would take 115 and multiply it by 0.767. And we'd get 88.205. We'd want to multiply that by 7.67. We get another. And then 51.89. And one more time, 2 more times. before we get to the sixth bounce. Okay. And we would get 30.526 feet. All right, so we could do all that. Okay, but an easier way is going to be, let's use the equation. Okay, right? We have y equals a times b dx. Okay, where a is going to be our starting value, which in this case is 150. Okay, our b value is going to be our multiplier, which in this case is our rebound ratio. And we raise that to the x. Okay, now if we want to find the sixth bounce, we're going to plug 6 in for x. Okay. Now our number is going to be a little bit off because we've rounded, but it's going to be pretty close. There you go. Okay, on the sixth bounce, it's going to bounce up to 30.540 feet. Okay, again, a little bit off because we rounded. When you use the equation, you're not rounding, so technically that's going to be a little bit more accurate. If you want to be more accurate, I guess, would be 150 times 115 divided by 150 as your multiplier, raised to the 6th. That would be the most accurate. But again, usually we have to round to 3 decimal places, so we'll just be doing that. Okay, so 6 bounce should bounce up to about 30.5 feet. The equation definitely a lot quicker. Okay, if I asked you for the 10th bounce, going all the way down to 10 would be pretty time consuming. Okay, but using the equation is always going to be a little bit easier. Okay, real quick, I want to sketch that graph and talk about a couple things. Okay, so we'd get a graph that looks like this. Okay, where we have our height as our y-axis and our bounce number as our x-axis. Okay, so just a couple things to just kind of talk about. We'll go into more detail later in the chapter. Okay, but notice one, obviously it's not a straight line, it's a curved line, right? I wouldn't connect these because you would only have a certain number of, you only have whole numbers for bounces. Okay, but notice with our equation, okay, our height is never technically ever going to get to 0. Okay, because if we think about it, we're always going to be multiplying something by 0.767. Okay, and unless that number is 0, that's the only way we'd get an answer for 0. Okay, but as long as you're taking 3/4 of something, okay, you're never really going to get to 0 in theory. Now, we all know if you drop a ball, it's going to eventually stop bouncing, right? Because of gravity, it's a thing that exists. Okay, But in theory, this is never going to touch the x-axis. It's just going to keep getting closer and closer. Okay, and that's referred to as an asymptote. Okay, an asymptote is a line on a graph that your graph keeps getting closer and closer to, but is never actually going to touch. Okay, because even if you say, what's the 100th bounce? Going to be, we get this number, this e to the negative 10 means we take this decimal and we move it to the left 10 places. So you get 0.000000433 something. All right. So really small number, okay, but I think we would all agree that if you dropped a ball, by the time it hit its 100th bounce, it would stop bouncing up. Okay, so this is referred to as an asymptote. All right. Questions on that?